Hai and Assalamualaikum. My name is Yusmi Shahira binti Muhammad Fauzi and my student ID is 2020463892.
Hello and Assalamualaikum. My name is Nur Alisa Shifa binti Muhammad Suki. My student ID is 2020468932.
My name is Aisha Hanani binti Nur Azhar. My student ID is 2020616982.
Hi, my name is Nur Alisa binti Abdul Ghani and my student ID is 2020482256.
Introduction of case study. Definition of Lami's theorem. Lami's theorem in static state that if three coplanar forces are acting on the same point and keep it stationary, then it obeys the relation where A, B, and C are the magnitude of force acting at the point and the values of alpha, beta, and gamma are the angles directly opposite to the force C, B, and A respectively. There are various types of swing that we know, such as tire swing, rope swing, baby swing, hammock swing, and many more. But the swing that we choose to completing this case study was the rope swing. Now let's look at the definition of rope swing. Rope swing are made from attaching one end of a length of rope to a tree-limb, bridge, or other elevated structure. On the opposite end, a knot or loop is frequently tied to avoid fraying and keep the swinger in place. Swingboarding is the use of shortboard, such as a skateboard, on which the rider stands. The use of connected board and harness is to keep the rider safer.
Next is the purpose of study. The theorem determines the forces acting on a moving body. Lami's theorem has been obtained from a sine rule for triangle by representing the forces as line as a free body diagram and translating them in such a way that one head touches the tail of another. Then it will be noticed that when there are three forces, if they are supposed to cancel each other, they resultantly form a triangle. If they are not supposed to cancel each other, they form an open curve. The sine rule is only applicable for triangles only, and hence Lami's theorem is only applicable to three forces. The theorem is helpful in determining the unknown forces acting at a point for an object in equilibrium.
Okay, let's move on to methodology. Alisa is sitting on a swing which is hanging with the help of two ropes. If Alisa has a mass 75 kg, determine the tensions in the ropes AO, BO, and CO. Degree for both sides is given as in the figure below. Okay, next we move to results and discussion. From the question, the mass is given, which is 75 kg. We also know the gravity always 9.81 meter over s squared. So we can calculate tension of A using the formula mass multiplied with gravity, which is 75 multiplied with 9.81. And then we get the tension of A is 735.75 Newton. To solve the tension of CO and BO, we can use Lami theorem, which is A over sinus alpha equal to B over sinus beta equal to C over sinus gamma. Okay, we solve the tension of BO using the Lami theorem. So we substitute the value of A, value of sin alpha, and value of sin beta. So we solve until we get the tension of BO is 538.62 Newton. To solve the tension of CO, same as the tension of BO. which is we substitute the value of tension of BO and also substitute the value of sinus beta and sinus gamma. From that, we solve the equation and we get the tension of CO is 659.67 Newton.
And lastly, the conclusion. Based on the discussion, we know that each thing can be calculated using an appropriate theorem or knowledge. As in discussion, after we used Lami's theorem to calculate, we found that tension at A equal to 735.75 Newton, tension at B equal to 538.62 Newton, while tension at C equal to 655.67 Newton. As we know, Lami's theorem can be used if we have the three forces acting at the point that are in equilibrium. Hence, Lami's theorem is an appropriate theorem that we use to find all the three tensions. If a simple thing like the tension at the swing can be calculated, then a complex things in our life can also be calculated. Therefore, there are no doubt that mechanics are a part of our life, consciously or
That's
not.
all from us. Thank you for watching.